おはようございます。お元気ですか？コロナウイルスは、とても怖って心配するけれども、手を洗って、うちにとどまってすれば大丈夫になると思います。あえっと、ブースマン先生、今日のレッスンを教えてください。All right, let's get started. Good morning. It's Wednesday, halfway through our second week of this new experience for us. Brief announcements to start our day. Your exit ticket today will simply be to submit a question you have from today's lesson. Again, if you don't have a question, then think of a question someone might have and go ahead and submit that. Okay. We're done with notes for 8.3, which means we're actually done with taking new notes for the year. You've actually learned all the new concepts that you needed to in AP Calculus AB. Forgive me as I get a little choked up over this. Now, the rest of this week will be practice for 8.3, and then next week we will review this unit and take this unit exam. I'm not going to sit here and go through every single problem for the rest of the mastery sheet. I will go through some of them, and then I'm going to ask you to work through the rest yourself. So today we're focusing on page 4. Okay, so page 4 are these 4 questions, number 5 and number 6. Okay, I'll go through a few of these here in this lesson, and then I'll ask you to continue working. I will also post this answer key today, so you can check your answers as you go on. All right. So these first 4 questions require the use of a calculator. A lot of you keep asking, when do I need a calculator? When don't I need a calculator? In general, I'm having you practice setting a lot of these up and stopping there, just because the setup is the most difficult part of these problems. So if you can get the setup, I trust that you can go on and actually evaluate the integral, find the antiderivative, and get an actual number for your volume. Sometimes your integrals are simple enough that you can do that by hand. Okay. If they are, then I make it very explicit on your unit exam, and then that would be on the no calculator part of the AP exam. Sometimes they are a little more complicated, like these problems are about to be. So you have a calculator, it would be on the calculator portion. Okay. If you're not allowed a calculator, but the integrals are kind of weird, usually what that means is you're asked to set up but not actually solve. That's a pretty common thing for these problems as well. So just read the directions very carefully. Sometimes you're solving, sometimes you're not. Sometimes you have a calculator and sometimes you don't. So here we have a calculator. Let's go through number 1 together. Here's x squared. And here is x cubed. There we go. Okay, this region right here. Okay, so we did need this point of intersection. Where does x squared equal x cubed? That happens at 1. Okay, so that line is there. This region is coming up out of the board and rotating around this line, creating a solid. All right, now we're rotating around a vertical line. So should we integrate with respect to x or with respect to y? If you said with respect to y, then you are correct. Okay. So our volume equals the integral from, who has the limits of integration for me? George? No answer. Yes, Colton? 0 to 1, very good. Pi times, now we have big R squared. Now, if we're on the axis of revolution, okay, big R is the function that's furthest away. So the function that's furthest away here, and remember, we want these in terms of y. So let's solve these. X equals the square root of y, and x equals the cubed root of y. So that function that's further away is actually the square root of y. And remember, this is function minus our axis of revolution, in this case, 1. Little r, the closer function, the cubed root of y, function minus axis of revolution. And we plug this in, we're squaring both of these. Big R minus little r squared dy, since this is in terms of y. This is a calculator question, so you would plug this into a calculator or Wolfram Alpha, and you should get approximately 0.209. Okay, so that's revolving around a vertical line. Let's practice number 2. So we're revolving around a horizontal line. All right, we have the region enclosed by the sine of x and x squared. So kind of a similar shape. And we're revolving this around the horizontal line y equals 1. This point of intersection, where does sine of x equal x squared? Again, use a calculator, some solving function, and they do actually intersect at 0.8767. Okay, so we are revolving this around this horizontal line coming up out of the board and around. So a cross section is a washer, and since we're revolving around a horizontal line, we are going to integrate with respect to x. Okay, so limits of integration are 0 to 0.8767. Pi times big R. Well, this is function minus axis. Now, if we're on the axis of revolution, which function is furthest away? It is x squared. So function minus the axis of revolution. And little r is the closer function, which is sine of x, minus the axis of revolution, dx. Plug this into a calculator, and you should get approximately, I did this before, 0.573. All right, so numbers 3 and 4 are very similar. Go ahead and work through those yourself. Check your answers on the key that I post. And in fact, I think, numbers 5 and 6 are very similar. I want you to keep practicing these on your own. They do get easier the more that you do them. Brief note, please, for number 6, go ahead and skip part B. So skip number 6, part B. There's actually an alternative to the washer method. It's called the shell method. It's very interesting, but it's never really required of you on the AP exam, so I don't bother going through that with you. If there's time near the end of the year, we can come back and look at it, but don't worry too much about it. But we would be using that alternative method for part B. Go ahead and skip that and finish all the others, okay? So your homework, your exit ticket today is due by midnight tonight. Tomorrow we will look at page 5 of this mastery sheet, and we'll look at pages 6 and 7 on Friday, okay? So reach out to me if you have any questions. Otherwise, thank you so much.
今日のレッスンが終わりました。じゃあ、どうもありがとうございました。また明日。